Okay, today we are going to talk about why lenses behave the way they do. What does that mean? Means that the convex lens we know converges while concave lens diverges. Why? Fine. To understand that, we are going to think of lenses as a combination of prisms. Of prism. Okay, we already know, we have studied the prism, so we know that if this is the prism, then a light ray is coming and incident at this point. So we are going to draw the normal here. So this angle is the angle of incidence. Now because it's a refraction from rarer to denser medium, light ray is going to go towards the bend towards the normal. So this angle is my R. Now it is incident at this point. So light ray is going to go away from the normal and it will move like this. Fine. We call this R dash. We call this E. And this is the angle of prism. So I can say if there is no light prism, light ray would have gone like this. But because of the existence of prism, light ray is going like this, right? So I will say this is the deviation it suffers. Now I know what is the minimum deviation. If delta m is the minimum deviation, then we have already derived the formula that mu equals to sine A plus delta m by 2 by sine A by 2. But we are not going to use this formula. Instead, to understand the nature of how deviation depends on A, we are going to take a approximation which is called thin prism. So for thin prism, we can say that the angle of prism is very small. Now I already know that the delta is equals to I plus E minus A and R plus R dash is equals to A. This is true for any prism. Now if A is small, both R and R dash are small. Again, sin I by sin R equals to mu. So is equals to sin E by sin R dash. Just think about the light moving, just retracing its path in the opposite direction. So for if R and R dash are small, I can also conclude then I and E are small. So I can say this formula, this expression becomes I by R equals to mu equals to E by R dash. So I can conclude I equals to mu into R and E equals to mu into R dash. Put that formula here, which will be delta will be equals to mu into R plus R dash minus A. But R plus R dash is equals to A. So mu minus 1 into. Now this is true only for thin prism. Okay. But the conclusion that we are going to derive from this, that is, if A is large, mu will also be, delta will also be large. This conclusion is true for any prism. Fine. Now we are going to think of the convex lens or the lenses as a combination of prism. What does that mean? So let us start with convex lens. So let me draw the convex lens. We have this, we have this. Now we are going to divide this convex lens into small parts. And if I look at any part, suppose I take this one. Now I can think of this as a prism. Why? Because if I extend this, it is going to meet at a certain point. So this becomes a prism and it's just a broken prism. Now, if I take this part at the edge, the prism, the angle of prism will become largest. Actually, A is maximum here and here. And A will be 0 here because these two line or rather these two plane will be parallel plane. But I already know that when light rays is incident at a prism with large A, then light is going to get deviated maximum. So light ray is going to incident at here is going to have the experience the maximum deviation and it will deviate towards the base. Similarly, light ray which is incident at this edge will experience the maximum deviation and it will deviate towards the base, this being the base of the prism. But the light ray which is passing through the middle section is not going to deviate at all. Okay, so because the angle of prism is 0. Let me draw this in a better way because it has not been. So it is going to go like this. It is going to go like that. Okay, and something which comes from in between is going to deviate less than the extreme one, but less than the one which is deviating from the edge, but more than the one which is deviating from the middle. So we can see that the light rays are is converging because of the convex lens. So light rays will deviate most towards the base from the extreme, from the edges, and will not deviate at all when passing through the middle. And this is the way the convex lens converges light. Similarly, if I take a concave lens, so let us first draw the concave lens. We will think of this as a combination of prism. The only difference is that this prism has a equals to 0. This prism has the maximum A. So is this prism. So it is exactly as before. Only difference is now the prisms are inverted. What does that mean? Means this prism now looks like this. And if I extend this, so this is how the prism looks like. So if a light ray comes and is incident at the middle, it will go undeviated. If it comes and incident at the edge, it is going to have the maximum deviation and towards the base. And if it comes from this edge, it will again have the maximum deviation towards the edge. Okay, and they are going to appear to diverge from a point. Okay. So this is how the lenses converges or diverges. Convex lens converges light and concave lens diverges light. Hopefully this is